begin talking about our different methods for volume. The first way we talked about was cross sections, and really remember those, and just know the formula, right? Just know which formula you're using and build it out. Our disk, remember we had to find our R, so graphing it and finding our R, we kind of have to take it like one step further, okay? Then with our washer method, it's a little bit different, okay? So what we're looking at is, let's say I had something like this, and this is my area that I am rotating. Yes? And I am rotating around my x-axis. And remember that we go from the outer edge of our region to our axis of rotation. Yes? But what do we notice about our R this time? Did I do it?
There's a gap on the bottom curve.
Ah, there is. So what's happening now, so remember that we're rotating at 360 degrees, yes? Which is why we said we end up with a disk. Yes, like if I slice it, I end up with a disk. However, when we start having things that have gaps in between, that means that I'm rotating that gap 360 degrees, and so we end up with a hole cut out of the middle of our disk, which is then why we call it a washer. Remember, use like screws, right? Sometimes you put washers on them to help hold them in. So like a washer is like a metal ring that has a hole cut out of the center of it. And so remember that our goal with our volumes is to take the areas of all of these disks and add them together by way of integration. Agreed? So now I need to find the area of this, right? So if this is my center, this is what we labeled as big R of x. Yes? Except now, is that going to give me my area by taking pi r squared? No. What do I also have to do now?
Track the inside circle.
Ah, so that inside circle we are now going to label as little r of x. And so we have to subtract so we have big R of x, so this gives us our area of the big circle minus our little r of x, which gives us the area of the inside circle, dx. And again, remember that these could technically be r, big R of y, little r of y, if we're in terms of y's instead of x's. Yes, no, maybe. Now, do notice that this is slightly different. We looked at one, remember, where we were like rotating around a different line, and so our big R of x had subtraction in it, right? It was like 2 minus x squared or something like that. But all of that still went into here, to this first one, to be squared as a group. Does that make sense? Versus this one is a little bit different because I have 2 separate things that I'm needing to square instead, okay? So that's why with these ones, they're not necessarily hard, it's just that the pictures, you have to do a little bit of thinking about like, what's the part that I want, what's the part that we need to subtract off. So, let's look at some examples. I would say that this one's a very common one on your AP test, okay? We like x squared and square roots of x, especially because like most students know what those graphs look like, or you should. Also, they're nice because they intersect each other, okay, at 2 different spots, and so we have bounds just inherently, like we don't have to have extra stuff going on. So notice that we are rotating around our x-axis. Agreed? And my stuff in between there is what we are rotating. Yes? So you would kind of like end up with like a, kind of like the parts of the flower, you know, stem that the like flower sits in on, you know, but like just that part. So there's like a scooped out middle part that we don't have anything. So when we draw our radius, okay, notice that I'm still gonna go to my axis of rotation, and that still goes through my like graph part that we want, but we need to get rid of this part, because really I only want the green portion. Yes, no, maybe. Okay. So I have v equals pi times, what's our bounds?
0, 1.
Hmm? So that's the other reason why we like these, is because they are nice, right? Like they intersect each other at nice spots. Okay. So what's my big R going to be?
Square root of x.
Mm-hmm. And then remember that we're going to do what with that in our integral?
Square root.
Mm-hmm. And then I'm going to subtract my like portion that I need to subtract off, which in this case is our x squared. Yes? Squared? So that's our little r. Yes, slowly. So what is the square root of x squared? Just x. Then x squared gives us x to the fourth. Okay. So what is our antiderivative of x?
1/2 x squared.
And our antiderivative of x to the fourth? 1/5. X to the fifth. And we're going from 0 to 1. So notice if I plug in 1, I just get 1/2 minus 1/5. If I plug in 0, what are we going to get? Just 0. Okay? And then for response questions, we would just leave it there. Okay? Multiple choice question, we would need to like condense them. So how would we add those or subtract those together? Find a common denominator. Okay? So my common denominator is going to be 10. So I have 5/10 minus 2/10. So we get 3/10. Or in other words, 3 pi over 10. Yes, no, maybe so. Alright, on our next one. Okay, so again, what's it helpful for us to do first?
Draw a graph.
Draw a pretty picture, right? Again, remember, it doesn't have to be the most accurate thing in the world, but it is really going to help us to be able to figure out what our big R and little r are. Sounds like a pirate. Okay, so again, we have x squared. I have y equals 0, which is going to be what?
Horizontal line.
At
0.
so the x-axis. Okay, and then I have two different points, or lines, sorry, at x equals 0 and x equals 4. So our shaded region that we are rotating, kind of like this curved triangle type spot, yes? Now, what's the only difference this time? 7, which is a, what type of line?
Horizontal.
Yep, it is horizontal. So still in terms of x's, because we're still horizontal, we're just not on our x-axis this time, okay? Now, where is y equals 7 going to be located? So like, where is this point? 4, comma.
16.
So then where would 7 be in relationship to that? Below it, okay? So I'm looking at something like that. Now, the first part that we notice, hopefully, is that like part of this is like above it. That's okay. Okay, it's that part actually kind of gets like scooped up into, since it's like overlapping, so we don't have to worry about that. However, we do have to worry about that when we start drawing our radii, what do we have here? We have a missing piece. Yes, no, maybe. Now, because notice, if I was just rotating around my x-axis, what type of method would that have been? Do I have a missing bit here? No, so it would have just been a this method, right? Now, because I'm rotating around something different, now I do have a missing bit, so that's why we end up needing to subtract off stuff. Yes, no, maybe? So sometimes your method is going to depend on what you're rotating around. So even if you have the same graph for like 3 different things, but you're rotating around the x-axis, the y-axis, or something else, it could depend on which method you're using. So our volume equals pi times, what's our bounds? Zero to 4, okay? And then we need 2 things. We need our big R and our little r. Okay, so big R of x, well, it's kind of nice because what is it? What's the length of that?
7.
7, right? It's just a like rectangle, right? So it's just a line. My length is just going to be 7. Now we do have to do a little bit of thinking with our little r though. What would our little r's distance be? Correct. So notice, remember that our distance between 2 things is, I subtract them. Specifically, we go top minus bottom. So it is 7 minus x squared. Notice that it's not just x squared, because x squared would give me the length of the stuff below that. Yes? Which, notice that that's not what I'm wanting to subtract off. I'm needing to subtract off the stuff above that. So in order to find this length, I have to do 7 minus x squared. So then we have 7 squared minus 7 minus x squared quantity squared dx. So how would we evaluate that? Yes, no, maybe.
We distribute it.
Yeah, you it's not distributing, you would have to multiply it out. Distributing is when I can apply it to each of them, right? I cannot distribute exponents. I can multiply it out, so you'd have to multiply 7 minus x squared times 7 minus x squared. Why can't I do a u sub?
You have an extra x.
Yeah, so when I let my 7 minus x squared be the u, you would be left with an extra 2x there, which the 2 is not a problem, but our extra x, I don't have an extra x there, so we wouldn't be able to do that. But for our purposes, we're going to just say this was calculator active, and we get 93.867. But again, remember, we do still have the pi there, so we have to put that with it. what questions do we have on that one? Ready to look at another one? Alrighty. So what are we going to do first? Graph it? Okay. What's the graph of 2x squared look like? Still just a parabola, right? But especially since I don't have any labels, it's technically been stretched by 2, but as long as it's still a parabola shape, we're good. Okay, and then where is y equals 0? Cool. And then x equals 2? Yes. So again, we are rotating a triangular curvy shape right there. Again, if I rotate that around the x-axis, which method am I using? Do I have a hole? No, not to my x-axis, so we could use the disk method. However, what are we rotating about this time?
Y-axis.
The y-axis. So now, when I go left and right, do I have a hole that I have to worry about for my y-axis? Yes. So we have to use our washer method. Now, two things. If I'm going left and right and I'm rotating around our y-axis, what do I need my equation in terms of? Y. So what do we need to solve for? Y is already solved for. I need to solve for x. So then I'm going to take the square root. Notice that I am dealing with the right side, so I'm dealing with my positive third. Yes, no, maybe. Alright, then next up we have to decide what our big R and our little r are. So big R, again remember, is the whole length. What is that? What is that length over distance?
2.
Yeah, it's just 2. Now, what is our little r?
2 minus 2x squared.
So 2 minus 2x squared would actually give us the shaded region. Just remember, it's like right minus left. So you would be taking this and subtracting off the red bit, so you would be getting this part right here. If I just want this part, my red line, okay, right is my 2x squared, left would just be 0, right? So it's just 2x squared minus 0, which is just 2x squared, but we have our, in terms of y, we would make it the square root of y divided by 2. Because again, remember that these are distances that are going left and right now. So they are in terms of going towards the y-axis. So from the y-axis to my function is just given to me by the square root part. Yes, no, maybe. Are we okay with how we count those? Then our volume. Again, the hard part is finding those two things. What are we going from? What are our bounds? Not 2.
Let's go to 8.
Yes. Y8.
Because that's when you plug in 2 for 2x squared, you get 8.
And that is the.
Where the x equals 2 is.
Yeah, but more importantly, that's the y value that's associated with that. Yes. And remember that if I am rotating around the y-axis and I have stuff in terms of y, my bounds must also be in terms of y. Yes, no, maybe? Okay, what's our anti antiderivative of 4 for y, antiderivative of y divided by 2, y squared, and we're evaluating from 0 to 8. Yes, no, maybe so. So 4 times y gives us sorry, 4 times 8, by plugging 8, 4 times 8 gives us 32. Minus 8 squared gives us 64. What am I going to get if I plug in 0? Okay, 32 minus 64 gives us
-32.
So we did one around x-axis, one around y-axis, run around our x equals stuff. Let's look at one more. What does 4x cubed look like? Yeah, it's like the S-ish shape, right? We're down on this side and up on that side. Yes? Then again, we are at y equals 0. This time we are at x equals 1. And what are we rotating about? Y equals -2, which is going to be a horizontal line, but notice that that horizontal line is below the x-axis. Agreed? That's going to change up some of our stuff. Now we're just going to do the setup on this one. Because on some of our questions, just for time's sake, it will say like set up but do not evaluate the figure that you would get from all of this stuff, right? So like we're just grading then on you setting it up, because then after that it's just intervals and such, okay? So I have b equals 5 times, what's our bound?
Like 0 to 4.
Nope. I agree with 0. What is this line at? X equals 1, right? And it's a horizontal line, with just like my x-axis is horizontal, right? If I'm around a horizontal line, that means that I'm in terms of x's. So I want x equals 0 to 1. Okay. Then we have to decide what our big R and little r. So again, I'm doing this region right here. So from my outer edge is my big R. From my inner edge is my little r. So, big R of x. Again, we can think about it like top minus bottom. Yes? So my top is 4x cubed. Agreed? What's our bottom curve this time? Huh? Not for my orange line. What's the bottom? Yeah, -2. Or in other words, we get 4x cubed plus 2. Yes, or we can also think about this, remember these are lengths or distances because they're a radius, right? So the distance from 0 to -2 is still 2, right? So I'm just adding that extra distance. I like to think about it as top minus bottom because then it doesn't matter if it's positive or negative. We can always use that and it just works itself out to add it correctly. just the portion that I'm subtracting off there. The red line. Huh? Be careful. Because again, it's an R, right? So it's a radius or a distance or a length. Or we can also think about it, my top this time is 0, my bottom is still -2, so I'm going to get a positive 2. Yeah. So again, we're just doing the setup on this. So we have 4x cubed plus 2 quantity squared minus 2 squared, which gives us 4 dx. And this is kind of the weirdest one that you can see, where like it's below the x-axis, so now we're having to kind of like subtract negative things, right? Yeah.
You just said that like if it's around the y-axis, it has to be in terms of y, right?
If it's around the y-axis, it has to be in terms of y, which means it has y's in the equation.
So how, like, why did you put 1 as the bound, not 4?
Because this one's not around a y-axis. Y-axis is vertical. So if I was going around a vertical line,
Yeah.
it would have y's in it. But this is the horizontal line. Y equals -2 is a horizontal line. If I had x equals -2, then it would be in terms of y, because that's vertical, like my y-axis is vertical. That means it's kind of opposite of our thinking, right? If it's y equals -2, that's actually like the x-axis. If it's x equals -2, that's like the y-axis. Good question. But yes, you're correct that if I was going around x equals -2, it would be 4 instead, because you would want it y as your bounds. Agreed. Other questions? Yes,